All right, so this is pages 10 and 11 from the review. So it starts with a turning point, right? Which of the following does a quadratic have its turning point? Well, the formula for the turning point is negative b over 2a, okay? And that is a is 5 and b is negative 12. All right, so we have negative 12 over 2 times 5. So this is 12 over 10, which if you reduce it, it is 1 2/10, or 1.2. Okay, and the only one with positive 1.2 is this one. Now, on your calculator, you really can't find it unless you do a minimum, right? So you can find these. We know that it's this shape because it's a positive x squared, right? That's 5. A is positive. So if you look on your calculator, you can do this. If you don't remember that formula, right, I'm going to clear this one, and then I'm going to put in 5x squared minus 12x plus 2. Okay, and if I just hit the graph, you can see we can see it. So then we can go second calc. It's a minimum, right? We're going to move this over to the left bound, right, to the left side of the turning point. Then we're going to move it to the right side of the turning point. And we get 1.2, negative 5.2, right? So that's also what this one was. All right. All right, which of the following do not lie in the solution set? Well, we can check all of these. We can factor x, make this equal to 0, x a minus and x a plus. All right, we get 3 and 2, 3 and 1, and that adds up to negative 2. So I have x is equal to 3 and x is equal to negative 1. Okay, so if you put these on the number line, it doesn't really help. So let's try something alternate, right? Let's take this out of here and let's try these points. We'll try one that doesn't work, and then we'll try the one that will work. Okay, so number 1, if we put in 0 is less than or equal to 4 squared minus 4 times 2. Yeah, we'll look for the one that doesn't work. 4 times 0, right? No, 4 times 4 minus 3. I got that wrong. Minus 2 times 4 minus 3. So this is 0 is less than or equal to 16 minus 8 minus 3. This is 8 minus 3 is greater than or equal to 0, and 0 is less than or equal to 5. So this one works. Okay, now we want to find one that doesn't work. If we look at number 4, right, we're going to try this one. We have 0 is less than or equal to 1 squared minus 2 times 1 minus 3. 0 is less than or equal to 1 minus 2 minus 3. 0 is less than or equal to negative 4. That's false, so that one is not in the solution set. So that's number 4. All right. So this one on the number line, we want to find the factors as if we were solving a quadratic, and we could find these two. They all have the same ones. They have what do they have? Negative 5, 6, negative 7, and 1, 2, 3. So we have x plus x minus is equal to 0. And we're going to put 7 and 3. That adds up to 5. So x equals negative 7 and x equals positive 3. Okay, now let's look at the symbol here. The symbol is less than, not less than or equal to. So that's going to be open circles, because they're not included in the solution set. So we can eliminate 1. We could eliminate 3. Now the last thing we could check is x equal to 0. And if x is equal to 0 is true, then we know that it's an end statement. If it's not equal to 0, it's an OR statement. So I have 0 squared plus 4 times 0 minus 21 is less than 0. We have negative 21 is less than 0. That's true, right? True. That's true. So therefore, it's an end statement. So it's going to be number 4. All right. So this one, all the answers are in the vertex form. All right. So we're going to change this to vertex form. 16x plus a number plus 5 minus that same number, right? And to get that number, we're going to do negative 16 divided by 2 squared. It's negative 8, right? Negative 8 squared is 64. So we're going to add 64 here, and we're going to subtract 64 here. Okay? So these three terms factor into two binomials that are the same, right? Oh, I'm sorry, half of 16 is 8. So it's x minus 8 squared. Y is equal to. And then 5 minus 64 is minus 59. Okay? Now, if they wanted to, they could ask you what the vertex is. The vertex would be at 8, comma, negative 59. Okay, but they don't ask that. So which one is x minus 8 squared minus 59 is number 3. Number 3. All right. Number 10, a reflection in the x-axis, right? So that means when you reflect something in the x-axis, if it starts here, it goes down here, the y-coordinate changes. Changes sign. All right. So if we're doing if we're going to take the negative of y, right, we also have to take the negative of everything over on the other side. All right. So that means that we're going to get y is equal to positive 2x squared plus 3x minus 8. All right. So 2x squared plus 3x minus, the last number is 2. Ooh, where did I get E from? I'm still on the last problem. 2x squared plus 3x minus 2. This was choice number 2. All right, on to the next page, page 11. The graph of the function f of x contains the point negative 4, 6. G of x is equal to negative 2 times, so we have a vertical dilation, right? We actually have a compression here. So this means f of x is really y, so negative 2x times y, right? That's what f of x really means, is the y coordinate. So we're going to take this negative 4 And then we're going to take 6 and we're going to multiply it by negative 2. And we get the point negative 4 comma negative 12. So that will be a point on the graph, which is number 4. All right, so now we have a circle, right? We have the center of a circle. Remember, the form of a circle is x minus h squared plus y minus k squared is equal to r squared. That's the general form. So we have the center, so we can write x, it's 2, the center, so we're going to make this minus 2 squared. And then we have y, negative 6. We have to change the sign also, plus 6. That's what the negatives mean, to change the sign. All right. Now, we're going to plug this point in so we can find out what r is. So we have 3 minus 2 squared plus 4 plus 6 squared is equal to r squared. This becomes 1 squared plus 10 squared is equal to r squared. This is 1 plus 100 is equal to r squared. So 101 is equal to r squared. And this is the one that has 101. And this has 101. Which one has minus 2 and plus 6 is choice number 1. All right, number 13. Lucky 13. Absolute values are have two cases, a positive case and a negative case. So we have to isolate the x minus 4, the absolute value of x minus 4. So we undo it just like on a regular equation. We would add 5 to both sides to get the absolute value by itself. Is equal to 12. 22. Whoops, that's an ugly 22. All right, so, and then we're going to divide by 2. Divide by 2, and we get, oops, this is absolute value. X minus 4 is equal to 11. So now my two cases are x. So we're saying that 11 can be inside the absolute value. So it could be a positive 11 because the absolute value of 11 is 11. And we also have to do when x minus 4 is equal to negative 11 because the absolute value of negative 11 is still positive 11. So we're going to add 4. We get x is equal to 15. If we add 4 here, we get x is equal to negative 7. Okay, so which one has negative 7 and 15 is choice 3. All right, let's see the next one. Factor the following polynomial completely. All right, so the first thing I always say, look for a common factor. 37, I believe, is a prime number, 7, 8, 9, 10. But we have an x common in that one, an x common in that one, an x common in that one. So the first thing we want to do is take out an x. Right? All right, we have x squared, 8x squared, minus 37x minus 15. Okay? And then we have to do a rainbow. 8 times, so we need a number that multiplies to be 8 times negative 15 and adds up to be negative 37. Okay? So I am going to go to my calculator. Right? And now it's not set up for what usually, but you may have to change a couple of times during the test unless you look for all of these first. But if we go to y equals, we want to do 8 times negative 15 is, oops, I gotta get out of here. 8 times negative 15 is negative 120. So we want to add up to, multiply be negative 120. So now we go back to the y equals screen. We're going to go to the y equals screen one more time. We're going to go up. We're going to clear that. And we're going to put in a negative 120 divided by x. And then we're going to do x plus y1. X plus vars. Move it over to y vars. Hit enter. And number 1. Okay, and then so when we go to the table, we're going to look in the last column for negative 37. Okay, so I think I have to go up. Whoop. I hit the graph button. Let me use my Apple Pencil there. There we go. So we're looking for negative 37. Whoop, it's right there. So my factors are negative 40. All right, so it's going to be x times x minus 40 and x plus 3. All right, we're going to divide both of these by 8 and 8. So it's x times x minus 5. This one's simplified as much as we can, so it's going to be 8x plus 3. Completely factored. Okay. Determine the x and y intercepts, okay, of this function algebraically. So the x-intercept, I'm going to do the x-intercept first because, I don't know, I just feel intercept. Because why not? The x-intercepts, and there could be more than 2 of these, happen when y is equal to 0. So f of x is y, so it's 0 is equal to x squared plus 4x minus 45. And then we could factor this, plus and an x minus. And these two factors are 9 and 5. So I get x is equal to negative 9 and x is equal to 5. Now this one says algebraically, so if you just do it on your calculator, you can, better to get the 1 point than to get 0 points, right? Or 2 points, you know, a point for the x-intercepts and a point for the y-intercepts. And you get 2 points instead of 0, right? If you want to go on your calculator and find them. The y-intercept is really kind of simple, but we'll do the algebra for it. Intercept, I mean, you could tell it's negative 45. Of course, this happens when x is equal to 0. So f of 0 is equal to 0 squared plus 4 times 0 minus 45, right? So this is 0 plus 0 minus 45. So f of 0 is equal to negative 45. Or we can say y is equal to negative 45. All right, so we'll end this one here. And I'll be back to do pages 12 and 13 in a little bit.